Alright, so now we're going to be learning how to find a slope-intercept equation of the line passing through two given points. So let's look into my graphing papers here. It's a computer screen, but it's working as my electronic graphing paper here. So what you have here is a situation where you have a line that is passing through two given points here. So one point we have here on the left here is the point with coordinate label here being -1, 3, and the other point are having coordinates 2, 1. So to briefly remind anyone about the slope-intercept equation, slope-intercept equation is in the form of y equals mx plus b. So where it's a linear equation, and this coefficient in front of the x term is regarded as the slope coefficient, and this constant term in your equation on the right hand side here is being referred to as the y-intercept. And another note I got to make here is that this y equals mx plus b is the equation, the slope-intercept equation of the line, but this is in equation form. But additionally, in some problem, the same equation here, the y variable on the left-hand side can be replaced with a functional notation. F of x equals mx plus b. So these are the exact two same equation. It's just the left-hand side here of this second equation I'm writing here is being replaced by the functional symbol f of x, indicating. So here we are in functional form. And now, after some brief review, let's go ahead and get into the learning how to do that. So right here is my graph. It's the graph of my line in red here. This line is passing through the two given points, and I repeat, the first point here on the left is at coordinates -1, 3, and the second point here to the right is at coordinates 2, 1. So it's not a must, but it has always been a highly recommended habit that anytime looking at a graph in mathematics, we always want to look at all those points in the order from the left to the right. So whichever point on the left is being considered as point 1, and the points to the right hand side is called point 2. Or this is, so if we regard to this as point 1, then -1, 3 is understood as x1, y1, and this point number 2 right here at coordinates 2, 1 can be generally understood as x2, y2. And so slope formula has always been known to be, in algebra, we take the difference in y values, and namely y2 minus y1, and divide by the difference in the x coordinates, so x2 minus x1. And that is our formula to find slope of any line. And so right here in this example, our slope right from the graph that we saw, then y2 is being 1 and y1 is being 3. So we have 1 minus 3, and we are dividing that by x2 being 2, and x1 is being -1. And so in this, all we have left now is to go ahead and complete the calculation. So 1 minus 3 is a -2. 2 minus -1, and you can see that I use parentheses very carefully anytime that I'm substituting a value. So here I'm substituting coordinates value 1 into my y2, coordinates value 3 into my y1. So I use parentheses for every substitution that I'm making. And so here my difference in the denominator becomes 3. So my slope here of this line is a negative 2 over 3. The next step is to find the y-intercept value. So let me make a note right here. We are about to now to find the y-intercept value, or namely the b value in your equation. And I still purposely leave the slope value here. And so the key in getting your y-intercept value here is that if we're looking back here, any one of these 2 points is given. And so you have your choice of selecting one of the points here, whichever one that's more comfortable for you. I would go with this point on the right hand side since it's having less sign. But like I said, if you're more comfortable with that point at negative 1, 3, that's fine too. Either point is going to work. But we only need to pick and select one point. So what I'm doing now is that I'm going to select one of the 2 points given here and substitute that into our current halfway found slope intercept equation. So currently our halfway found slope intercept equation is being y equals negative 2/3 x plus b. And so b, the constant term b, is still remaining unknown here. And so in that case, as I said earlier, we're now going to take one of the 2 points, the 2 given points from the graph, and substitute that in. And I made my choice here to select that point is 2, 1. And so now 1 is the value for y, 2 is the value for x. So now we're going to simply just substitute those values in place of this equation. X for x, y for y. So left hand side becomes 1. There's the equal sign. There's the slope value being negative 2/3. And the x value is substituted by 2. And then plus b. And so at this point, what we have here, now let's go ahead and clean up the 2 sides a little bit so that so it looks a little more cleaner. So here 1 equals a negative 4 over 3 plus b. In case you are not comfortable with looking at the equation this way, you can make your choice of rewriting the equation to contain the unknowns on the left hand side. So this equation can be logically equivalent with writing that as minus 4/3 plus b being on the left equals 1. These 2 equations are logically equivalent, so you can write it whichever way that you are more comfortable with. So the point now is that from this equation here, we are going to add. So how about I'm going to go with this the form of the equation where I believe a good majority of people are more comfortable with this way, putting the unknowns on the left hand side. But it would work the same if we stay with this form. I am now going to add that 4/3 to both sides of the equation here. And so now left hand side cancels out the 4/3, that which left behind for us b equals, and so the right hand side now is just a matter of adding 4/3 with 1. So here let's do a little math here, but 1 plus 4/3, the math gives me 7/3 right there. And of course anyone viewing this video should be fluent with adding or subtracting fractions, so allow me to skip mentioning how we add 1 with 4/3 to become 7/3. But that is now our y-intercept value. And so now, concluding our equation, then if we are looking at just the traditional x and y equation, then our equation is y equals the slope values being negative 2/3 that we found previously times x plus the y-intercept values being 7/3. This is just in the traditional x and y equation. In case you need to express your equation in functional notation, as a functional equation, then it's going to look just simply replace the y variable here with the f of x symbol. So f of x as a function, f is a function in terms of x, and the expression for that is negative 2/3 x plus 7/3. And that's how we are writing it. Now, if we roll back to the beginning of our step where we starting to find the y-intercept after we've had the slope of the equation calculated, we have a different alternative here. So if you know how to set up the equation of the same line right here, if you know how to set up the equation as the point slope equation. So, but this skill provided you already know in hand how to find the point slope equation. But the point slope equation is like this. Say I already mentioned that the two given points here, you have your choice of selecting any of the 2 points here, and I made my choice in my earlier explanation that I'm going to choose this point 2, 1. So with my chosen point, being 2, 1, then point slope equation is quite convenient sometimes because it's simply just formulating the equation by doing y minus 1. The 1 here came out from the y value of your chosen point, and equals the right hand side is simply the expression negative 2/3, where this 2/3, this negative 2/3 came from your slope, and multiply with a parentheses expression. Inside of the expression we have x minus 2. So this 2 right here came out from your x value, from the x value of your chosen point. So this equation here, and throughout my steps here, I hope I also remind you enough in case the skill of finding the point slope equation has faded away for anyone, but it's that simple. So this equation here is to be considered as it's being regarded as the point slope equation of a line, of any line. And so the alternative I was mentioning here is that once you've had the point slope equation, then we can do a little algebra. So the right hand side, we can go ahead and distribute that negative 2/3 into each term inside of parentheses, but be ready for some sign change here. So negative 2/3 times the positive x gives me a final terms after distribution, minus 2/3 x minus 2/3 times negative 2 is going to give me consequently plus 4/3. And then on the left hand side we're looking at y minus 1. And so at this point right here, to arrive at your final slope intercept equation, all you need is now just add 1 from both sides of the equation. And so consequently your equation becomes easily y equals negative 2/3 x plus adding the two fractions here, the fraction 4/3 with 1 is now going to give me 7/3. And once again, this equation is our slope intercept equation, and it's just in the traditional equation. But in case you need to express this in terms of a functional notation, using the functional notation, then simply just substitute your y variable on the left hand side here with the functional f of x notation. So a different form of that is f of x equals negative 2/3 x plus 7/3. And that's how we're done finding the equation of finding the slope intercept equation of any line passing through 2 given points.